Hello, 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 hello. Hello and welcome and welcome and welcome. Thank you so much for joining us today. I know that we had a little bit of a disruption yesterday because just realised I've got my microphone in, because our internet was letting us down. So thank you so much for coming today, and so that I don't feel all lonely and you're here. So I'm just looking at the names. Yeah, I've got some new names and we've got some people who have joined us before. So welcome, old friends and new class friends. Good to see you having a careful chat before the lesson starts. So let's be good and ready now for maths thinking so that I can see all the comments are related to maths. Okay. So as I said, join the chat before we start the chat about 15 minutes for the lesson. So if you do want to come and just say, hi guys, how are you? And without giving any personal information away, as you know, we've got to be careful, then please make sure you join the chat before so that when the lesson starts, you are good to go. Hi, Miss Nikki. Hello, you too. Lovely, lovelies. Can you give me a thumbs up or show me your emoji of preference to show me that you are ready? Ready to start with your maths brains all good to go. Let me see what I'm going to have coming in today, what emojis I am going to be delighted with. Did you like? Yep, no memes, please, today. Just let's focus on the maths. Let me see your emojis. Hi, hi, hi. Hi is okay. Let me see. I'm good to go. Let me see what you're going to show me. Thank you. Here they come. Oh, what we got there. Woo, nice. Okay, hi is fine. Hi is fine. Pictures are fine. Ticks are fine. Smiley faces are fine. Oh, and here they come. Here they come. The emojis. Oh, nice smile. Nice teeth. Nice eyes. Nice little tears. Okay, brilliant. Keep those emojis coming so I can see that you're ready. A tick is great as well. Very, very good. Very clear. Very nice. Lights up my screen. Makes me know that you're there with me. So at the end of last lesson, I sent you some problems, some brain teasers to think about. And we put the link in the chat, but we also sent it as an attachment for your grown-ups. So can you tell me, did anybody manage to do those problems that we sent through? Does anybody manage to do the problems that we sent through? Yeah, anybody manage to do them? Because I'm going to go through them today. So some people did. So the first one was this. Each long side measures 7 meters. So let's have a little look. Who can get it? Who can get it? How much is that short side? Have a little think about it now. There's the rectangle. There's the information that you have. Okay. There's the rectangle. There's the information that you have. How much is that short side? So we have a rectangle. The perimeter we are given. It is 26 meters. We know that this measures 7 meters. We want to know what's that side. That's the big question. What does that measure? The perimeter is 26. That side is 7. What's that side? Are you busy thinking? Are you busy thinking? Okay, are you busy thinking? Got some answers coming in. Well done, well done. And I got some correct answers coming in. Okay, if you're lagging, don't worry, because remember, it does catch up. Okay, so we know that the total comes to 26. I'm going to do the maths calculation inside the shape so that you can see. Okay, so we know that 7 plus 7 is 14. So that's what that side and that side comes to. And we know the total of all 4 sides is 26. So we've got 26 equals 14, because that's what there, plus A plus A. Okay, so those are the same. So that's what we know we've got to do. So if we take 14 away from 26, it leaves us with 12. So 12 equals A plus A, or 2 times A. So what's half of 12? Half of 12 is 6. Not 6 potatoes, 6 meters. Remember your units. So that side equals 6 meters, 6 meters. Well done. Well done for those who got it. And there were quite a lot of you. There were quite a lot of you. So just think through, Okay, what do I know? What information have I been given? I've been given the perimeter. I know what one side measures. So how can I use that information to reduce the unknowns till I can solve the problem? Okay, until I can solve the problem. Now, the other problem I gave you for homework was this one. I'm going to drop the screen down so that you can see this, because it's quite a lot of information to take in. But you need to start thinking, what is the information telling you? You need to start thinking, what is the information telling you? So 4 children are in a race. Okay, there's the 4 children. That's their numbers. And I want you to match the numbers to the children using these clues. Okay, so I'm just going to move that up so you can see the bottom. 4 children in a race. There's the numbers on their vests. Okay, so one child's number is 350, one child's number is 53, one child's number is 35, and one child's number is 3,500. Okay, yeah. So using these clues, Jack's number is 10 times smaller than Mo's. Alex's number is not 10 times smaller than Jack's. Dora's or Mo's. Dora's number is 10 times smaller than Jack's. Now we can see the 10 times factor coming up here, can't we? With these numbers that we have. We can see the 10 times numbers coming up. Yeah. So there are the numbers on the vests. There are the clues. Jack's number is 10 times smaller than Mo's. Alex's number is not 10 times smaller than Jack's, Dora's, or Mo's. Dora's number is 10 times smaller than Jack's. Now have a little think about working systematically. Who can you rule out straight away from that 10 times? Who can you rule out straight away from that 10 times? Who can you rule out straight away from that 10 times? Who can you rule out straight away? Okay, who can you rule out straight away? You can rule some out straight away, can't you? Yeah, you can rule some out straight away. So think about Alex's number is not 10 times smaller than Jack's, Dora's, or Mo's. Alex's number. A thinking phase. We are thinking. We are thinking. I can feel the thinking vibe coming through the paper, coming through the Wi-Fi, coming through the ether cable. It's not recorded. I am listening and I have moved. So we can do this together. Okay, I want to think about how you can be systematic. Okay, let's put this up because people are still saying they can't see the whole page. Okay, so this is what we had. This was the problem that we had. Okay, so 4 children are in a race. These are their vest numbers. Okay. And we want you to match the numbers to the vests. Now, Jack's number is 10 times smaller than Mo's. Alex's number has got nothing to do with 10 times for any of them. And Dora's number is 10 times smaller than Jack's. So what I would do is I would look at those 10 times first of all, and I would say, well, I've got 3,500, I've got 350, and I have got 35. I know that they are all 10 times smaller than each other. And then I've got this random 53. So I put my numbers out. I know that Alex's number is not 10 times smaller than Jack's, Dora's, or Mo's. So that is Alex. Alex could be a boy or a girl. So he or she is not involved in it at all. Okay. So let's have a look. Jack's number is 10 times smaller than Mo's, and Dora's number is 10 times smaller than Jack's. So they go in that order. Jack is 10 times smaller than Mo, and Dora's number is 10 times smaller than Jack's. So I'm going to hold that up. Okay. So these are the sort of questions I am setting you to do for homework, where you can see all the script. And the idea is that when we come back, we can go through them together. The idea is that when we come back to the next lesson, we can go through them together. So if you can manage to have a look at the questions, we put them in the chat and we send them out on the emails as well. So if you can manage to do that, that's absolutely brilliant. Okay, so let's, just before we go on, I just want to check that you are all using your tables to help you do sharing. I'm going to draw an array up here. Okay. I'm going to draw an array. Let's have a look. Oh yes, we'll do this one. So you count the array that I'm drawing as I draw it. Okay, here it goes. So count the columns. Immediately you'll be able to see what times table it is by counting the columns. Now, can you write for me, please, the two multiplication equations and the corresponding two division equations for that array? Can you write the two multiplication equations and the two corresponding division equations for that array? Two multiplication and their corresponding division equations. Okay, two multiplication and their corresponding division equations. Look into that array. Okay, so I've got 1, 7 lots of 4. So this person has counted the rows. 1, 2, 3, 4, 5, 6, 7. There are 7 rows, and each of those rows has 4 in. So that's one multiplication. 7 times 4 is 28, because there are 28 in total. Okay, 7 times 4, yep, can see that one. Oh, not 4 times 4. That would be 4 times 4, wouldn't it? That would be 4 times 4. We've got 7 lots of 4. 1, 2, 3, 4, 5, 6, 7. And in each of those rows, there are 4. So that's doing the 7. Okay, so somebody has said yes. So 7 times 4 is 28. Okay, so 7 lots of 4 are 28. Then if you divide 28 into 7 lots, you will have 4 in each lot. They are related, aren't they? Yeah. 7 4s are 28, because if you divide 28 into 7 groups, there they are, 1 group, 2 group, 3 groups, 4 groups, 5 groups, 6 groups, 7. You will have 4 in each group. What's the other one? What's the other one? 7 4s, and have I missed it? Somebody put it in there. Oh, there it is. There it is. Now we can count the rows, 1, 2, 3, 4, 5, 6, 7, and say there are 4, or we can count the columns. We can go this way, like this, or we can go this way, like this. And when we go this way, there are 4 columns, 1, 2, 3, 4. 4 columns, 4 columns, each with 1, 2, 3, 4, 5, 6, 7 in them. Still 28. Still 28 in total. Hasn't changed. The amount has not changed. We can just count them in different ways. We can group them. We can group them. Okay. So if 4 7s are 28, then 28 divided into 4 groups will give us 7 in each group. Will give us 7 in each group. So either 7 lots of 4 come in this way. Okay, so I can do the rows. There they are. Either 7 lots of 4, there they are, 7 lots of 4, or 4 lots of 7. 2 different multiplication equations with 2 different division equations. 2 different multiplication with 2 different division. So let's have a look. I'm going to give you another one to do. Let's have a look. Can you please give me the 2 multiplication and the 2 division equations for that array? The 2 multiplication and the 2 division equations for that array. 2 multiplication and 2 division equations for that array. I put a new array up for you to see on the screen. Can you give me the 2 multiplication and the 2 division equations for that array? Okay, so counting them carefully. I am going to count the rows to help me here. I'm going to count the rows. So I've got 1, 2, 3, 4, 5, 6, 7, 8 rows. I've got 8 rows, okay? And then I'm going to say how many is in each row. 1, 2, 3, 4, 5, 6. Okay. So for me, that's what I'm going to do first. Then I'm going to do the corresponding division equation. Okay, somebody says 8 and 5. They're not counting carefully because I counted 6. Okay. Then I'm going to go by columns. How many columns have I got? 1, 2, 3, 4, 5, 6. How many have I got in each column? So let me see the 2 multiplication and the 2 division. Nice emoji time sign there. So there we have. So first of all, I counted the rows. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 rows of 6 in each row. 8 times 6 is 48. The corresponding division equation, 48, shared into 6, gives me 8 in each one. They are the 4 equations from that array. Okay, they are the 4 equations from that array. Did you get all 4? You can write this on your paper. You don't have to type them in, and then you can just give me some feedback to let me know that you got them. That's absolutely fine. Okay, got half of them, got them. Lovely emojis coming through, lovely ticks showing me that you did. 100%, nice little graphic there. Yeah, okay. So let's flip this over. Give me the 4 equations, please, from this array. Give me the 4 equations from this array. Okay, think about rows and columns, whether you count the rows first and then say how many's in each row, or whether you do the columns first. Does not matter. The total will stay the same. Multiplication is commutative. You can swap them around. It does not matter. I'm going to do mine over here. Okay, so you can do them on paper. Like I said, it does not matter. And I want to see your 4. Oh, nice, nice, nice. Yeah, lovely. Coming in, coming in. Okay, let's have, oh, wow. Big time signs, big statements. Okay, let's just have a look. Keep those answers coming. Okay, these are the 4 equations from that array. These are the 4 equations from that array. Okay, they are the 4 equations from that array. Let me know whether you got them all. Did you get those 4 equations from that array? Let me know if you did. Okay. Let's ask a question in another way. So well done. I'll just leave those equations there so you can just double check whether you got them. So I've got some friends coming over. Let's have a look who's coming over. These are my friends who are coming over. Okay, who else is coming over? Oh, he was going to come over. He's lost his head. Not very helpful. Who else is coming over? Let me see who's coming over. They're nice friends. They are nice friends. Let me have a little look. Who else I've got coming over? Oh, there I've got some friends. They're just waiting here to be asked. There we are. I've got some friends coming over. Here they are. Here are my friends coming over. Okay. There are my friends coming over. Yeah. Now, when we come to play party games, okay, and this is me here. This is me, my party. If I want to put my friends, if I want to put us in two groups, can I do that? If I want to, there's me. Okay. Just check that we're all in there. Yeah. Can I put my friends, including myself, into two equal groups? And if so, how many will be in each group? How many will be in each group? Okay. I am part of the 8. Yes, I am part of the 8. I am going to join in. Yeah. Let's not get distracted with the characters now. I know it's interesting. You can talk about them in the chat. Yes, I can, because I'm coming in and we can go into two groups of 4. Okay. If I want everybody at my party to have 3 sweets, including myself, how many will I need? If I want everybody at my party to have 3 sweets, everyone to have 3 sweets, how many sweets will I need? Use your times tables. How many sweets will I need? If everybody's going to have 3 sweets, how many will I need? Easy peasy. Come on. Easy peasy, 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 peasy. Yeah. I will need 24 because 3 times 8 equals 24. Okay. Because 3 times 8 equals 24. If I have 64 minifigures to give to my friends, and I also am going to have some, how many can we get each? If I have 64 minifigures and I'm going to share them out, including myself, how many will we get each? If I have 64 minifigures to share, how many will we have each? If I have 64 minifigures to share, how many will we have each? Very clear. Thank you. That number per person. Excellent. Very, very clear. Oh, hello. Some nice new names today. Hello. Welcome, new friends. If I have 64 minifigures, how many are we going to get each? Show me the multiplication sum, the multiplication equation you use to work that out. Even though it was a sharing, show me the multiplication equation you would use to work that out. 64 figures, 8 people. How did you know it was 8? Write the multiplication equation for me. Okay, write the multiplication equation. Excellent responses. Absolutely, absolutely. Fantastic. In it comes. We know it's going to be 8 per person because we absolutely know that 8 times 8 is 64. 64 divided by 8. Some people had it so embedded in their head, they absolutely knew. Okay, let's focus on the maths. Brilliant. Well done. Well done, brilliant thinkers. Okay, I've still got 8 there. Now, my mum came in with a box of 100 biscuits. 100 biscuits. How many did I give to my friends? Not me, my friends. How many did I give to my friends? So these are for my friends. My friends. I don't get any. None for me. None for me. How many do they get each? How many do they get each? How many do they get each? How many? We're going to get a sugar rush, but I'm going to tell my friends they cannot eat them all together. I made nice little boxes for them, and they have got to eat them carefully. Thank you for your health warnings. How many do they get each? I'm not going to break my biscuits up. I'm not going to break my biscuits up. Okay? They're going to get whole biscuits, and I'd like to know then how many I get left with. How many whole biscuits can I give them in my little box, in my decorated box? Yeah, I spent a long time making nice little boxes for them. They get a little box to take home to put the biscuits in. A nice little box. So 100. How many do they get each? What are 12 sevens? Think about what 12 sevens are. 12 sevens. Some of you have said 12. If you know your 12 sevens, then you should know they're going to get more than 12. Because when you do that, you've still got some left over. You've still got some left over. So it's more than 12 each. Now 12 times 7, because I'm not included in this, remember? Remember I said I am not getting any biscuits. So there's 7 of them. 12 sevens are 84. 12 sevens are 84. So I can give them more than 12 biscuits if I do 2 sevens on top of that is 14. Then actually 8, 98. I can give them 14 biscuits each. And how many do I have left? How many do I have left? How many do I have left? I can give them 14 each, and I can have 2 left for me. 2 left for me. 2 left for me. So let's just be absolutely clear how we can use our tables to help us with our sharing. How we can use our tables to help us with our sharing. So I could give them 14 biscuits in a box to have 1 a day if they've done some exercise, and I've got 2 left for myself. I've got 2 left for myself. So thank you, friends. Woo, what a great party. Thanks. Thanks, Nicole. Great. We'll come back again. Woo. Okay, good. We will come back again. Now, last week, hey, sugar rush. Thanks for the health warnings. Last week, we thought about what happens when we scale up, when we multiply by 10 or we multiply by 100. So let's think this week what happens when we do it the other way. Okay, so when we multiply by 10, we jump to the left. Okay, so there's the 10s, there's the 1s, there's the 100s, there's the 1000s. Yeah. If we make 10 times bigger, whoop, it comes over to the hundreds. We make 100 10 times bigger, whoop, it comes over to the thousands. So let's have a look when we share. Okay, let's have a look when we share. Just remind ourselves so that we can use that to help us with sharing, use that to help us with doing harder multiplication and division facts so that we can keep them in our heads. So if we have, let's have a look if we've got 10s. So if I've got 3 10s here, and I have got to share them amongst 10 people, how many do they get each? Really easy. How many do they get each? How many do they get each? 30 divided by 3. Oh, no, I said 10, didn't I? Sorry, 30 divided by 10. 30 divided by 10. Yeah. They're going to get 3 each. So I've got to break these 10s apart and make 10 groups of 3. So when I divide by 10, 30 goes the other way. So if I divide by 10, it jumps over there. So when we multiply, we get 10 times bigger by 10. When we divide by 10, we get 10 times smaller. So let us have a little look down here. Let's come down to the place value chart so we can see the place value chart. So if I had 3 100s, there they go in the hundreds column, and I divide by 10, what do they become? If I have to share those 3 100s out amongst 10 people, what do I get? If I have to share those 3 100s, share them by 10, what do I get? Okay, divide 300 by 10. What do I end up with? Well done. Answers coming in. Answers coming in. Okay, 3 100s shared by 10. Exactly. We would get 30 each. They would move over to the 10s. We would get 30 each. If I shared those 10s by 10 now, what do I get then? If I share those 10 by 10, what do I get then? If I share those 10 by 10, what do I get then? 3 10s shared by 10, what happens then? Oh, a little rhyme. 3 10s shared by 10, what happens then? 3 10s shared by 10, what happens then? If somebody is being silly, just ignore them and focus on your maths, because if you give attention, then they carry on doing it. Okay, let's just focus on the maths because you are doing fantastic maths together. Okay, well done. If I shared 10, 3 10s by 10, I end up getting 3. Okay, so let's use that math to help us do bigger problems. Okay, let's use that math to help us to solve bigger problems. Let us think about how we can use maths to help us solve bigger problems. Now, if we know, I've just got to make sure that you can see all of this. I'll bring that up a little bit, and I will bring that up a little bit. Yep. So if we know that 32 times 5 is 160, how can we use it to solve this? Let's do this one first. If we know that 32 times 5 is 160, how can we use it to help us solve this? What is the answer to this? What is the answer to this one? If 32 times 5 is 160, what is the answer to this one? Okay, it's the inverse. Exactly, exactly. So what's the answer? So what's the answer? It's the inverse. So what is the answer? 32, exactly. Because if 32 times 5 is 160, then 160 put into 5 groups would give you 5 groups of 32. Okay, now look about this one. In your head, 160 divided by 32 might take a little bit longer, but if you know this information, what's the answer to this one? 160 shared. Exactly. Answers coming in really quickly. Super focus, guys. Super focus. Exactly. So if we know that 32 lots of 5 is 160, then when we share 160 by 32, there's going to be 5 in each group. Okay? Do that one for me then. Knowing this, what's the answer to that one? Knowing this, what's the answer to this one? We just do one more. We just do one more, and then we will come back to this, and I'm going to give you one problem before we go. I like to just do one little problem before we go, and we can carry on with more of these next time. Exactly. Let's have a look. Exactly. We know that because then that is 160. We will do some more of those on Tuesday, but let's just do one little brain teaser before we go. Let's just get one little brain teaser before we go. Okay, can we see this? Can we see this? Josh has £250, lucky Josh, in his bank account. Kyle has 100 times more than that. 100 times more than that. More than Josh. How much more money does Kyle have than Josh? How much more money does Kyle have than Josh? Have a work of it out and put your answers. You might want to work it out on paper. You might want to work it out on paper. Work it out on paper and let me know how much more. Oh, it's much more than that. Much more than that. Kyle has 100 times more than Josh. How much more money does Kyle have than Josh? How much more money does Kyle have than Josh? How much more money? How much more money does he have? How much more money does he have? Let's just see if anybody... Oh, answers are coming in. Oh, listen to the question. Listen to the question. It doesn't ask you how much money does Kyle have. It asks you how much more money does Kyle have. It doesn't ask you how much money he has. It asks you how much more money. I have not seen the correct answer come in yet. I am still waiting. I am still waiting. Is anybody's brain awake enough to work this out? I have not seen it yet. I have not seen it yet. It has not come in yet. So Josh has £250. Kyle has 100 times more. How much more money? I've just seen the right answer come in. Well done. Now I've seen it again. Aha, we've got one correct answer so far. And another person. No, it's the same person who keeps putting the answer in. There's only one person who's got the correct answer so far. And now another person has. And they're coming in a bit more now. Oh, we'll have to go through this because lots of you have been challenged. Lots of you have been challenged. Now, Josh had £250. Kyle had 100 times as much. So that is 25,000. Not 2,500. That's 10 times as much. Kyle had 100 times as much. So you had to do 2 jumps over. Then you have to see what the difference is. Well, take 250 away from 25,000. 24,750. Well done. 100 times 250 is 25,000. 2 jumps over. 2 jumps over. Where's my place value chart gone? 250. 100 times bigger. 1 jump. 2 jumps. 25,000. 000. Okay. 2 jumps. Just be thinking carefully about that. So, well done, chickadoodles. Lovely. Thank you for joining me today. Let's give you a celebration. Woo! Now, I hope that you have all subscribed to the YouTube channel and asked your grown-ups to share the channel with as many people as possible. We are going to send you some brain teasers to do after the lesson, and I will start Tuesday's lesson by going through those. So please, 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 please have a go at them. Makes it so much more interesting for you if you have. So have a little go. Oh, can we see Rexy? Yes, he is here. Thank you. There he is. There we are. He can come over the top. Now, Rexy was naughty last night. I'll just tell you a little quick story. Last night, we went out to clap for the NHS and the key workers and the train and bus drivers and delivery people and all the people who are working really hard and, you know, putting themselves in a bit of danger. We went out to clap, the neighbours, and I let Rexy out. And normally Rexy is too scared to go off the front lawn, aren't you? But last night, because it was quieter, Rexy went off the drive into the road. Never done that before. So Rexy is in the doghouse today, aren't you? So Rexy will not be allowed out without his lead on because he cannot be trusted. Because it was quiet, he thought he would go and have a little walk across the road. So that was not good. And Mummy had a heart attack. Well, nearly did. So thank you very much. we will put the activity in the comments section. So just read what we've put, the Bright Idea comments. We will put that in the comments section afterwards, and we will also send it as an attachment to your grown-up so they can see it as well, and they can share it with you. You don't have to print it off. You can just look online and you can just work it out, do your own little drawing. Remember, if you want to send me pictures of your work, then that's fantastic. I'd love to see them. I'd love to see what you're doing. And we will start next lesson by going through the problems I've sent you. I've sent 2, and we will start on Tuesday by going through those, okay? So well done. We will be scaling up and scaling down using our 10 times 100 times, divide by 10, divide by 100, and doing some more work around that on Tuesday, as well as some problems to make sure that you are really, really thinking about the application. Thank you for joining. Thank you so much for coming today, even though I couldn't join you yesterday. I missed you all. Lovely to see people that I've seen before, and welcome new people. It's lovely to see new names. Have a good weekend, chickadees, and I will see you on Tuesday. Take care, stay safe, have a go at your homework, and I will see you on Tuesday, my lovely chickadees. Lovely to spend time with you. Bye-bye. Bye. Bye-bye.